What's going on, Internet? So what if AI could book your dinner reservations, check your calendar to ensure there's no conflicts, and even email you notification of when that was done, and all doing it on its own without you? The important thing here is that it's not about better models to get that use case, but actually it's an unspoken thing that's not discussed often, which is a protocol. And it's a little protocol called MCP, or Model Context Protocol, as we can see here on the screen. You can think of this as the USB-C for AI. It's the universal connector that brings AI to the rest of the world and allows it to act amongst those different services and data sets in the world. And this is exactly what we're going to talk about today. MCP, the protocol created by Claude, but can be used by everyone. So we'll start with slides, as always. So here we have the example that I gave previously, but in more detail. So let's assume that we have our user here, and our user wants to ask AI to book a reservation, to book a dinner specifically, and they're interested in sushi. So they go up to the AI and say, hey, book a reservation for me at one of the top restaurants associated to sushi in this specific location. So the AI is going to have to go off and do a bunch of things to achieve that task. So the first thing it's going to do is going to go off and, okay, it's going to search for the top places that have sushi in that location. Once it's kind of distilled it down to the top 5 or 10, it's going to then make a decision. It's going to say, okay, I want to go with this place for whatever reasons or constraints that we had previously. It's going to review the reservation times. It's going to check those. And it's actually going to check those against our calendar. And once it checks our calendar, then it says, okay, we see an open spot. And we're going to book a spot in that opening. And we're going to book it here through this reservation API. And once we booked it, we're then going to email that back to our user and notify them and say, hey, we booked a reservation at the sushi restaurant on this day at that time. Now, for this entire flow, it's important to note that there's a really important underlying infrastructure, which is the MCP protocol. Because if we didn't have that protocol, to build this flow out would be quite convoluted and complicated for a lot of developers to do. And the reason being is our AI, most of the time, is boxed off. It's siloed, and it can't reach out to the world. It can't see other data sets. It can't do any of that stuff. But if we incorporate that infrastructure, that MCP layer, it's going to be hard to say that a lot throughout this video, we have to add that into the section. So for instance, this one here, that's a protocol. We have to call out to search for something to find information. That's something that AI usually doesn't have access to. And the same thing applies to our reservations. We have to check the reservations in the restaurant site. We also have to check our calendar, so that either could be Microsoft or Google. We have to book the reservation through a place like OpenTable. And we also have to use email to send the email back to our user. So these are all different interactions and points where the MCP protocol is really key for us to actually have our AI interact with the outside world. And the best analogy I could kind of convey this to you is through charging ports. So I'm sure many of you have experienced the pain that I have over the last couple of years, where you have maybe your headphones, your tablet, your laptop, and then maybe one other device. And each one of these devices have different form factors for charging. So there's different ports. So maybe our phone does USB-C, our headphones do whatever that is, our tablet does this, and our laptop does this. So that kind of sucks because we have to bring all these chargers with us at all times if we're traveling. And if we forget any one of these, then our device is kind of screwed. If it dies, we can't charge it. We have to go buy another cord. And then all of a sudden, you have maybe, like I did, 10 of these, 5 of these, maybe 20 of these or whatever reason, and then maybe like one of these. And that doesn't work out too well. Now, this has improved because a lot of us, I'm sure many of you that have modern devices, everybody has kind of concluded that USB-C is the charging port that everybody wants to use. So now, today, my tablet, my phone, my laptop, all these different devices all use USB-C. So I can use one cord for all my devices. And this is called a standard. So a lot of different providers of devices have standardized on a specific charging port, making it easier for the users. And this is really critical for AI because that's exactly what MCP has done. The MCP protocol here has been created to act as a standard, not just for one specific AI, but all AIs. And not just for one specific tool or data set, but all tools and data sets. It's a common standard everybody is trying to adopt. And if they all adopt this successfully, we're actually going to have a very specific protocol that we can use to interact with the outside world with our AI. Now that's the analogy. Hopefully that resonates with you. Now I want to do a demo. I want to show you exactly what is this and why is it useful. And yes, this was created by AI, and I think it's amazing. All right, we're going to show you an example here with Claude. So I'm going to go to Claude and I'm going to ask, what was the investment Apple wanted to invest in AI recently? Okay, so this is our question that we're going to ask Claude. And this is Claude 3.7. It's February 27th, etc., etc. So we can see that it comes back and says, hey, sorry, I can't respond to that because my knowledge has been cut off as of October 2024, which is kind of a long time ago. So it makes me question what models they're working on today. Anyways, you can see they actually can't get this data because they don't have access. And this goes back to the point, is our AI is siloed in a very specific cage, and it can't reach out to net new data sets that it hasn't been trained on, or new tools like Google, Slack, whatever else. So it's limited in its capabilities. Now, the next one here, now this is Claude again, but this is Claude on my device. So what you just saw there was Claude in the browser. So this is a Google Chrome browser. And then this is the desktop Claude. Now, what I've done with desktop Claude is I'd set up MCP, a specific tool with a protocol to research things online. And if you look at this little like hammer down here, you select this, these are my MCP tools. And these are tools that allow me to extend my AI's ability to get new data sets and take specific actions. And the tool I'm using right here is Brave Browser Search. So it's allowing me to do local search on my machine and also web search. So I'm going to ask the same exact question, but I'm going to say use Brave to search, like that. I'm going to say enter. So once I do enter, it's going to go off and it's going to ask for my approval. It's going to say, hey, is it okay for you to go off and do the search? I then need to approve this and say, yes, it's okay. So there's a human in the loop to ensure that we're being safe in our search. So now Claude's going to go off online and search for that very specific question to see, okay, what was associated to this investment in Apple? And it got it correct. It was 500 billion. That's what I was looking for the commitment for the future of not just AI, but a bunch of other things. And if we actually do this drop down, you can see all the different websites that Claude went to get this information. So you can see it went to Reuters, it went to Investopedia, went to TechCrunch, CNBC, all these different places to get the information, consolidated that, and then generated a response back to me. Which is really cool because what we've done there is we expanded the AI's ability to do different things and interact with the world around us through a protocol that is likely standardized amongst all the AIs and tools. So the way you set this up is if you're using Claude Desktop specifically, and I'll talk more about how you can use this for all things, is you go to Claude, you go to settings, not check for updates, whoops, Claude settings, and then up pops this thing here. So you then go to developer, you go to edit config, and that's going to open up a folder. And inside of this folder, you want to go specifically to the Claude _desktop _config.json. And that's where you put in your configuration. And to find these configurations, let's go to the internet. Where's the internet? Here we go. MCP, that's not what I'm looking for. We can do this. All right, cool. So you can find these different MCP servers, that's what they're called, as these are basically little ways to communicate with these tools outside of your AI's restrictions. And this is one for Brave Search. So in here, it gives you specific instructions on how to set this up. So first you need to get a Brave API key. Then you need to subscribe to a plan, likely the free one because it's 2,000 queries a month. You need to generate the key, and then you need to set up your specific file that I showed you. And we're going to skip over Docker because we're not using that. We're going to use the npx. And here you basically just copy and paste this JSON blob into that file I shared here. So you paste it into there, and then you just replace this with the API key that you pulled from Brave. Once you've done that, you'll have to reset your Claude desktop. So you'll reset the desktop. Where is it? I lost it. Here, you'll have to reset this, close it out, open it back up. And once you've done that, then you should have this little tool down here that says that it's actually set up correctly. If not, it'll give you an error, and then you can try to figure out how to fix it with AI. So that's how you set this up. That's not really what this video is about, but I figured I'd share that with you just in case you were interested. Now, back to the slides. So we've talked about the demo, and now what I want to show you is the phases. So how have we evolved to this point where we think MCP is critical? What pain have we had to endure collectively to get to this state? So the first part is the phase one piece that I mentioned previously. So previously we have our AI, so that's our AI, and this is its cage. It's a really bad way of writing cage. So cage. So the cage is basically mentioning previously that the AI cannot reach out to net new data sets if it's not been trained on it, the point that I made previously with Claude around Apple's investment. In addition to that, it doesn't have the ability to use tools. So it can't go out and check my Slack messages, or maybe go and check my email, check my calendar. maybe even pull customer data from my CRM or whatever else. It can't go off and do that for me because it's not connected to it. So it's restricted, it's caged in. That's historically where we started collectively as a community around AI. Then we evolved to this next phase, where a lot of these developers were having great ideas. And they're like, oh, what if we connected our model to net new data so it could actually do research online? Or what if we could, have our model look at our Slack messages, consolidate those, generate a summary, and feed that back to our users? So they're coming up with all these great ideas of how to connect AI to other things. But the issue here is they're siloed in their excitement. They're like, oh, this is a great idea. I'm going to build it. So they have a silo, they build the idea. Then they have another silo and they build that idea. And they build that idea. And all these different startups and all these big tech companies had developers building very custom integrations. So they kept on reinventing the wheel over and over and over. And by reinventing the wheel, they're both kind of wasting their resources and also not sharing the learnings with other people so we could actually collectively move faster in getting our AI to interact with the world around us. So this phase 2 is where we kind of are right now, and we're slowly getting up to phase 3. But this was a type of pain that's been endured by many different companies, both the big AI companies and also the AI startups that are working with them. So this is what's happening today. Everybody's building custom integrations for specific things for their AI and not sharing it with anybody else. But then that's when we move on to phase 3. So in phase 3, this is kind of where we are today. So I'd say if we had to decide, we're kind of like right here, in time. So let's this is us, a little stick figure. We're kind of in between phase 2 and phase 3. And MCP was actually created by Anthropic. And Anthropic, out of the good of their hearts and some other stuff I'll share later, they've created this protocol that can be shared amongst the community. So instead of everybody creating these great ideas in silos, they actually create the idea once, and they then share this idea with all the different startups and communities. So everybody can actually get access to this effort they've built out with MCP. So they built their specific connection to MCP, and they share it with everybody else to use. And this is kind of where we are today. And the point I want to make around this is, how did we get to this? Well, Anthropic, OpenAI, all these big providers built out a bunch of integrations for their models. And they realized that they kept on spending a lot of time in building and building and building. And as they built all these custom integrations, they also felt firsthand the effort they had to recreate the wheel every time for a new integration. So that's the firsthand impact. But the secondhand impact is all these big AI companies actually work with tons of AI startups. And the AI startups were having the same complaints that they were facing themselves. So that impact was amplified by hundreds and thousands of AI startups with these big AI companies work with. So the pain was very acute and focused. So they could feel that and hear it. And once they felt that and hear it, they realized, okay, we need to figure out a solution. And one of those solutions they came up with is MCP. So let's create an open standard for everybody to build on top of so we don't have to recreate the wheel over and over. So that's phase 3. Now, to my strategic advantage rant. I couldn't help myself. I had to share this. So this is a common strategy that many companies use, that MCP. So I mentioned this came out of the good of the heart of Anthropic. Yeah, sure, it was a good of the heart, but also there's a thing here where this is a strategic advantage for that company. And the reason being is they're seen as slightly behind OpenAI. So if we see this as a race, we have OpenAI here, and then we have Anthropic here. So Anthropic is the creator of Claude. So they're slightly behind, and kind of as a starting line, they're behind OpenAI. Everybody kind of perceives and sees this as such, kind of the collective society. I don't know if this is true. I think a lot of the Anthropic models are actually better than OpenAI's, but that's neither here nor there. That's just the perception of society, which is important for these big companies. So what do? They do what every other tech company has done in the past. They either create something that's open source or open standard to catch up. So if you're in second place in any competition in tech, this is the type of strategy that we tend to see. I want to give you some examples. So Kubernetes. Why was Kubernetes created? So Google created Kubernetes because AWS and Azure were both ahead of Google's GCP provider. So Google provides their service of GCP, and they said, okay, well, we need to figure out a way to catch up. And a way we can do that is by creating Kubernetes that allows people to easily switch between cloud providers. So that gave them an advantage. And this was an open source standard that they created for the community. A lot of people adopted it, and it gave them the upper hand in a sense that they could actually get people to move over them faster. So they're still not in the lead. So this is still the ranking. We have GCP, Azure, and AWS kind of set up like this. But they're catching up, and they're able to catch up with for a variety of reasons, one of which is the creation of Kubernetes. That's our first example. Our next one is Android, also from Google. So this is where we have iPhone versus Android. And in this competition, iPhone is a closed ecosystem, Android is an open ecosystem. So you can develop on top of Android, iPhone not so much. And this is when Android was created. So Google was behind in the operating system for phones. So they created Android, they made it open source, and then a bunch of companies built on top of this operating system. So we have Samsung, we have Motorola, we have all these different providers that have these kind of phones that at the base level have Android. Google benefited from that because it helped them catch up to iPhone when it came to operating systems. So this is another approach to catch up from second place. And then finally, we have Meta recently created an open source model called Llama. So Llama is Meta's way of trying to catch up to the other providers. So if we have OpenAI, say OpenAI is up here, Anthropic's here, Meta is probably like here. So they're definitely not in second place or first place. I don't know if they're in third place, but they're somewhere, in the back of the line. So if this is the case, what they did is they created an open source model, Llama, and they released it to the community. And they did this because they're kind, but also they did it to catch up. In the sense that they can actually open source innovation. So if everybody starts adopting their open source models for their own purposes, they then feed back those innovations that they come up to build things more efficiently, higher quality, etc. They feed that back into Meta because they're building on top of their models. So they get to benefit of the open source collective innovation for their own purposes. So this is another way for them to catch up from second place. So this happens all the time, right? And that's exactly what's happening here, where we have OpenAI. They, in the past, had something similar to MCP, but wasn't open source. So ChatGPT from OpenAI, they had ChatGPT plugins, and they still do. But this didn't necessarily catch fire. So they had a marketplace where people could utilize these plugins and play around with them with their chat interfaces to interact with different places like OpenTable. They could interact with, I think they had stuff for Slack and other things like that. And they also had another variant of plugins, which was function calling. So they still have this and it's still used, but this is their approach of extending the AI model's ability to get out of the cage. So to get access to other data sets and tools. So they set up this way, but it was closed. So that's the premise of this box here, is it's closed only to their models. So only OpenAI models can utilize these tools to reach out to the world. So they're creating custom integrations and custom setups for themselves, hoping to create a marketplace around it to have other people build on top of it to help them, get faster reach for their models to other things. But it didn't necessarily take off. This is where MCP stepped in from Anthropic, because remember, they were in second place, and they needed to figure out a way to catch up, or at least to catch up in this sense. So they created a thing called MCP, which I mentioned previously. And this is the same version of a plugin. So we're basically creating a protocol where everybody can plug in their tools and services to AI, irrelevant of whose AI it is. So it doesn't have to be Claude's, it doesn't have to be OpenAI's, it doesn't have to be Llama's or Meta's. It could be anybody's model. And they can utilize the standard to connect to services and data sets. So this is their way of trying to catch up by using this specific protocol. All right, talked more about it than I thought, but hopefully it was useful. So now, how does this work? How does this actually function? What is the overall setup here? So currently, for today, this is what the flow looks like. So we have your computer inside of this box here, and we have the internet down here in this box. And the MCP client is your computer. So this is likely your computer or something else. And so actually, let me take that back. I said this is your computer, right? So the client is likely going to be an application. So a client could be the Claude desktop setup I showed you here. So the Claude desktop app is a client. The Cursor, so Cursor's IDE is a client. There's a bunch of different types of clients that can interact with these servers. So think different apps that we use day to day that have AI in them. Those are considered clients. Then we connect all these clients to MCP servers. And these MCP servers act as translators. So they're basically sitting between our AI model and data sets and tools outside of our AI model's reach. And what it's going to do, it's going to have this MCP client that has our model inside of it. It's going to communicate in a way that's in the standardized protocol. So we're going to communicate in the MCP protocol, hence this text here. This is the MCP protocol that's being communicated. And when we communicate in this standard way, we're then going to send that off to a translator, which are these servers here. And these servers are going to translate our MCP language, the protocol that it speaks, to the thing that it's reaching out to's language. Because the language outside of here, so outside of here, both on the machine and outside the machine, these are all custom languages. They're all specific to certain APIs, databases, etc. So it's acting as a universal translator between what our MCP protocol is, the standardized, and everything else. So once it translates that MCP request, it's going to send that off to something. So it could be a local setup inside of your computer where you're asking the AI to actually modify files in your machine. So that could be a local variant of this. Or it could be reaching out to the internet like this, and it could be going to a remote server to do a certain task. So that could be going to Slack to summarize messages. It could be going to your email to summarize emails or write an email. It could be going to your calendar to check if you're available, etc. So this is the remote aspect where it's going out into the internet to do this. And it's using web APIs, which is the specific language that our MCP protocol doesn't speak. So we're going to translate into that API language. We're then going to get a response back. We're going to translate it again through our MCP server back to our API client, or MCP client. So this is kind of the process and how it functions. This has turned out to be a very ugly drawing, but hopefully that makes sense. All right, so now we're going to go off and look at some marketplaces, because I mentioned previously that the standardization of this, now luckily we have an entire community of people that are building these MCP servers. And all these MCP servers connect to very specific applications. And it's kind of like an app store for AI. So we're creating an app store for AI to download all these plugins to use these different tools and data sets that the AI can then reach out to. And I'm going to show you some of these examples now. So this here are just examples of clients. So these aren't servers. I just wanted to highlight this before we go to servers. As we have example of clients, so I mentioned earlier, we have Cursor, we have the Claude desktop that I mentioned, Cursor, all types of clients here that I mentioned that are available via the, I think this is the Claude documentation site, but there are more clients that are just listed here. So in addition to that, these are some of the formal servers that have been listed by Claude as well. So Anthropic has listed out all these file servers that you can do. So you can see you have a server for Google Drive. You have one for GitHub. You have the Brave Search one that I mentioned previously. You have one for Slack, Google Maps. All types of them are listed here. So this is the one that's from Anthropic. But there's also, like I said, the open source community that has a bunch of servers they're building and sharing with each other. And that's what these marketplaces show. So Klein itself is kind of like a Cursor, but not Cursor, but Klein. They have a bunch of plugins as well. So you can plug these into your IDE, and your IDE then can interact with these other services. So these are all different types of servers you can search through, download and use with your AI from your IDE when you're coding things. We have another one here for MCP. So this is just an open source community that shows different types of MCP servers from MCP.so, and then another one from Glamma.ai. So these are a bunch of MCP servers as well. You can see the different types of filters here. And then we have the one that I showed you for Brave. So those are just a bunch of marketplaces that exist today where people are sharing these different servers that you can download and utilize and have your AI then reach out to the outside world. And it's important to note that some of these MCP servers can be quite finicky, because right now we're at the early phases right now. So we're in early phases of going between phase 2 and phase 3 of actually getting a more robust standard for people to build out more secure ways of utilizing these tools. All right, so we talked through that. And then the next thing here I want to talk you through about is the roadmap. So I don't know if I have this still up, my slides. Yeah, so here, this is basically a blog from Anthropic talking through a roadmap. So this is a roadmap that they have for the first half of 2025 of extending the MCP protocol and kind of making it more robust and improved. And this specific roadmap that they have listed here, there's a primary focus, and that primary focus is remote reach. So they want to actually improve the MCP protocol's ability to remotely work with servers instead of solely focused on the local side. And what do I mean by that? Well, if we actually go back up to this diagram quickly, you can see that all of the servers here are sitting on our computer. So we have to download the MCP server. We have to set up the configuration in a convoluted way. We have to then ensure that that server is working correctly and calling out to the right thing. So we have to do a lot of setup and things like that. That's not necessarily user-friendly. So this here, all these MCP servers, we don't necessarily want to have to discover and set them up on our local machine. We want to make that an easier, more fluid experience. That's likely everything should be sitting in the cloud somewhere. And this is our cloud. Everything should be sitting in the cloud, all the servers, and we should be able to interact with the internet in a more streamlined way. And that's kind of what the roadmap's trying to achieve. And that's what I'll show you here. So first things first is today is what we have with MCP. Tomorrow is what we'll have at the first half of 2025, if they can deliver MCP as expected. So the first thing is security. Right now, we're basically using passwords. So we're using API tokens and passwords that we have to set up in our JSON file that I showed you previously to then connect to these MCP servers. That's not super secure. In the future, they're going to try to use a collective standard, which is OAuth 2.0, I think. And that's a common authentication standard that many of the apps we use today have. So it's basically a more secure way of communicating with applications. Next, another thing they're going to do is discovery. So right now, I showed you all those marketplaces that you have to go through and find different servers that you think are relevant for your use cases. You have to then download it, you have to set it up, you have to do all that stuff, which isn't fun. In the future, we're going to use magic to auto-discover these servers. Now, it's not necessarily magic, but if they set this up correctly, what they're going to do is they're going to have AI figure out which MCP servers are relevant for the task at hand. They'll reach out to those different servers to figure out which ones are relevant, automatically configure and set it up, and then utilize it with your approval. So this is going to drastically reduce the friction that users have today for using these new tools and data sets with their AI set up. And then the last one is the local point that I made previously. So right now we have all of our servers sitting on our machine, but instead of doing that, we should set it up in the cloud, and we should really kind of expand our ability to bridge the gap between AI and these kind of new tools and data sets with this protocol, so we can effectively communicate efficiently. And by doing that, if we put all the servers on the cloud and we improve the communication between our machine and those, we can really increase the throughput of our ability to have our AI utilize these tools and services much faster. And why is that important? It's important because if we live in a world of agents, these agents will have to use tons and tons of different tools and data sets and interact with all these different MCP servers in a very fast and kind of seamless fashion to ensure that the user has a really great experience with their AI. So this is really critical as well. And then I'll end with this. So this is kind of the last slide and last point I wanted to make. And it really comes down to when you're creating an open standard, success really hinges and hangs on the network effects associated to this. So if the open source community and also all the vendors that have these these tools and data sets, if they start to build more of these servers, the motivation will increase for those that have AI baked into their products to build out MCP clients. So those MCP clients then can gain access to all those servers. And as more and more MCP clients are built, the motivation increases for both the providers and community to build more servers. So it's kind of like a flywheel. So if we can continually improve our ability to continue this momentum of adopting and effectively implementing MCP servers and the overall MCP protocol, we could have the future that we all want. Because I'm not sure about you, but I would like a future where we have a bunch of agents that are seamlessly working with all of these tools and data sets, pulling context from each one of the interactions with these tools and carrying it forward to know exactly what happened in the past, to know what to do in the future, and then making these actions and doing these actions effectively so we can actually create this world that we want to see with agents. With that being said, internet. I hope you found this entertaining, educational, all that. So please like, subscribe, reshare with your friends. And if you'd like to work with me, I have a company called Gradient Labs where we actually help people implement AI internally to automate their processes, become more productive and efficient. So if you're interested, you can book a call below. There's a link that we can book a free 15-minute conversation to see if there's a good fit. And internet, I will see you next time.